we proceed with analysis of a variance approach to the regression analysis, which is from this analysis of variance approach, we will create or build the Anova table. Okay, so analysis of variance is the term of statistical analysis that break down the variation in data into separate pieces that correspond to the different sources of variation. So, semuanya berkenaan dengan deviation dan juga variation. It is based on the partitioning of sum of square and the degree of freedom associated with the response variable y. So, kita akan partitionkan sum of square. Kita akan ada SST, SSE dan juga SSR. Okay, and then dia punya degree of freedom. Okay, we need all of this to create the Anova table. But before that, you kena tahu dulu macam mana the formula of FST, SSE dan SSR created. In the regression setting, the observed variation in the response Y comes from two sources, okay, which is, okay, it is conventionally measured in the terms of the deviation, okay, perbezaan, the deviation di antara YI dengan Y bar. Okay, YI dengan Y bar. Okay, contoh dekat sini. I tunjukkan the illustration. Dalam your textbook ada dekat page 64. Yang ni chapter 2, page 64 ada dia punya figure and all the explanation actually. Okay, so kalau kita tengok from the figure A, it is the deviation between YI dengan Y bar. Okay, this deviation are shown by the vertical lines. Okay, the measure, kita cuba tengok figure A kat sini. The total deviation of YI minus Y bar. Ini adalah illustration untuk kita cari measure of the total variation, which is SST. Okay, which is SST. If you can see here, okay, the deviation, total deviation of YI minus Y bar. Okay, so garisan ni, this line, okay, this line adalah line of Y bar. Okay, line of Y bar, straight line kat sini, the vertical line, Y bar, itu Y bar. Okay, and then all the dot kat sini, point semua ni adalah observation of Y. Okay, observation of Y. So, the deviation di antara Y bar, maksudnya line ni, dengan Y for every observation, total of the deviation adalah SST. So, kita akan kirakan deviation between Y1 dengan this line Y bar plus the deviation between Y2, this point dengan line Y bar, then plus pula kalau ada Y3 minus dengan Y bar and so on. Total of all this deviation adalah SST. Okay, itu untuk SST, the first figure here, figure A. Okay, figure B pula adalah illustration untuk kita dapatkan SSE, which is it is the deviation of YI minus Y bar, kan? SSE adalah error, kan? Sum square of error that we know tadi, untuk dapatkan SSE adalah summation of EI square. So, the deviation between these adalah, okay, okay. So, garisan ni, line ni, the straight line here adalah the regression line, which is dipanggil regression function ataupun regression line yang kita dapat from the OLS method sebelum ni. Y hat equal to beta naught plus beta 1 x. Ini adalah line Y hat. Okay, so the deviation between YI dan Y hat adalah, let's say for this one, Y1, okay, tolak dengan Y hat. Dia punya regression line dekat sini. And then, tengok pula point yang kedua, Y2 dengan y hat ni. Berapa dia punya deviation. So total of the deviation of yi dengan y hat tu dan squarekan dia. So you akan dapat SS. Kita akan dapat SSE. Okay. And then SSR pula adalah, okay, SSR kalau kita tengok daripada illustration dekat sini, okay, ni garisan y bar. Okay, so actually SSR adalah deviation between y hat dengan y bar. Okay, so ini y bar, garisan vertical line y bar, dan ini adalah regression line y hat. So the deviation between this vertical line dan juga y hat adalah total of that dan squarekan dia dipanggil SSR. Okay, dipanggil SSR. Okay, boleh nampak boleh faham macam mana kita illustrate how to get the sum of square, of total, of error dan juga of regression. Okay, so if we can see here daripada illustration tadi, kita akan dapat total variation equal to the deviation of the fitted regression SSR plus dengan the deviation around the fitted regression line SSE. Okay, so this part bila kita masukkan summation, so dia akan jadi SST equal to SSR plus SSE. So actually untuk create the formula of SST, SSR dan SSE, it comes from the illustration of the deviation between mean dengan observation, the deviation between observation dengan fitted value, dan juga the deviation between fitted value dan juga mean. Okay, right, ini benda sama. Okay, saya cakap tadi ni, ini adalah value of the formula of SST. From there we know that the formula of SST adalah summation of yi minus y bar square. And you should know also that if SST is 0, so maksudnya the deviation between the mean and the observation is 0, means that all observation are the same, no variability. Tiada variability between mean dan juga y. Maksudnya dia punya y bar is 0, right? So tak ada variability between mean dan juga y. So SST will be 0. The greater is SST, the greater is the variation among the y values. Okay, so kalau kita dapat SST tinggi, means that the deviation between yi dengan y bar ni also greater. Okay, because of that, the greater is SST, the greater is the variation among the y values. So the deviation between the observation, kalau you boleh bayangkan from the illustration tadi, dia punya observation dan juga vertical line y bar tu jauh lah. So dia punya variation will be greater. When we use the regression model, the measure of the variation that the observation variability around the fitted line, which is the y hat. Okay, so yang ni tadi daripada the illustration tadi, the measure of the variation in the data around the fitted regression line is the value of SSE, which is the summation of yi minus y hat square. Okay, ataupun itu adalah deviation of error. And then last kali the formula of SSR, so actually dah tunjuk tadi, which is the summation of yi hat minus y bar square. Another name dipanggil regression sum of The larger is SSR relative to SST, the greater is the role of the regression line in explaining the total variability in Y observation. Okay, in order to create the ANOVA table, we also need to know about the degree of freedom for each of the sum of square. Okay, so this part that I mentioned just now, this is the SST equal to SSR plus SSE. Okay, so the breakdown of the degree of freedom for each of the sum of square ni adalah, okay, n minus 1 will be the degree of freedom untuk SST. Why n minus 1? One degree of freedom is lost, okay, because we estimate the population mean Y bar. Okay, so because of that, the degree of freedom will be n minus 1. Okay, untuk SSE, dia punya degree of freedom is n minus 2, means that 2 degree of freedom are lost because of we estimate the parameter beta naught and beta 1 daripada sini. Okay, so sebab tu dia lost to degree of freedom n minus 2. Okay, and then untuk SSR pula, the degree of freedom for SSR is 1. Because of actually 2 degree of freedom are associated with the regression line beta naught and beta 1. But one of the 2 degree of freedom tadi lost because of we estimate the Y bar. So because of that, the degree of freedom is 1. Okay, so untuk create the ANOVA table, we need to divide the sum of square tadi with its degree of freedom. So because of that, MSR will be SSR divided by 1, MSE equal to SSE divided n minus 2. This ANOVA table that we talk about is for when we analyze using the simple linear regression, means that we have only one independent variable. Okay, so this is the ANOVA table that you are very familiar with. Okay, so nak create this ANOVA table, kena betul-betul tulis dia punya source of variation, kena ada regression, kena ada error dan juga total. The next column will be SS. Notation for sum of square you will put the value of SSR here, value of SSE here, and value of SST here. So how to get all this value? We have the formula. So I believe you all pun dah biasa with the formula of SSR, SSE dan SST. So the third column kat sini adalah column untuk degree of freedom. For SSR is 1. Okay, kalau if we deal nanti dengan multiple linear regression, dia punya degree of freedom for SSR kat sini will be different lah. So kat sini 1 degree of freedom because of we deal with the one independent variable. So SSE dekat sini n minus 2 sebab kita deal 2 sebab kita deal dengan a simple linear regression that we lost 2 degree of freedom because we estimate the parameter beta naught and beta 1. Let's say you ada 2x, your parameter you akan jadi 3 kan, beta naught, beta 1 and beta 2. So dekat sini will be n minus 3. Then SST is always n minus 1, which is the total of the degree of freedom of regression dan error. So the next column adalah mean square. Okay, mean square column, which is you need to divide each of the sum of square with its degree of freedom. So MSR equal to SSR divided by its degree of freedom 1. MSE equal to SSE divided its degree of freedom n minus 2. And last kali last column, lastly we can calculate or determine the F value, which is MSR divide dengan MSE. So our intention sebenarnya last kali untuk dapatkan value of F ni. This value F we will use in order to chart the significance of the regression model. Okay, later we will go to the hypothesis. We will includes the hypothesis testing in our analysis. Okay, so this is for the formula that you are familiar with before this. Okay, untuk the formula for SST. So SST actually adalah SYY. So how to get the SYY? This is the formula, right? Summation of yi square minus summation of y square kan all the value divide dengan n. Untuk dapatkan SSR, we have two formula, whether you use beta 1 multiply dengan SXY ataupun you can use SX, X which is beta 1 square multiply SX, X. Okay, so you know how to find SXY dan SXX tak ada kat sini. SXX will be summation of XI square minus summation of X, all of that square divide dengan small n. Okay, so untuk dapatkan beta 1, this is a formula which is the SXY divide dengan SX X that you have done before this. So last kali untuk dapatkan SSE, just SST minus SSR. So once we have all the value of sum of square dan juga mean square, last kali our intention untuk dapatkan value of F kan from the Anova table. Last kali we will get the value of F value that we will use to test the significance of the regression model. Okay, the formula kat sini ni that I mentioned here adalah the formula when we deal with the simple linear regression. Okay, untuk multiple linear regression we have the other way to find the value of or the sum of square error ataupun the value to get the Anova table. Okay, this is the test of the significance of the regression model ataupun regression function that you are familiar with. Sama juga you dah pernah jumpa sebelum ni. Okay, so kena ada hypothesis, H0 and H1. So because of we deal dengan simple linear regression, so kat sini adalah parameter satu je sajalah untuk beta 1 sahaja. Beta 1 equal to 0, beta 1 not equal to 0. If beta 1 0 means that the slope is 0. Kalau slope 0, you takkan ada regression line. Okay, so kalau kita fail to reject H0, kita accept H0 means that the regression function atau regression model are not significant, which is there is no linear association between y dan x. Okay, when we reject H0 means that we accept the H1, which is beta 1 not equal to 0, which means we have the value of beta 1, the slope. So we have the regression line, so we can say that the regression model are significant. Okay, so once we have the hypothesis, we need to mention the significance level of alpha that is controlled by the researcher, and then we have the test statistic F, which is the value from the Anova table tadi. And then the decision rule is we will reject H0 if the test statistic F more than the F table. Okay, remember how to get the ataupun how to read the F table from your statistical table yang merah tu. I believe all of you ada. Kalau tak ada, kena dapatkan Anova table tersebut sebab nanti you will use the statistical table in final exam dan juga in final assessment and all the other assessment pun you kena gunakan we will use that statistical table lah, to for your PNP. Okay, so kena ada. Kalau tak ada, try to get that, ataupun you boleh inform saya kalau if ada lagi lah, saya boleh tolong postkan ke macam mana. Okay, kena ada. Alright, so dia punya critical value adalah F alpha. Remember, kalau F table tak perlu, you punya significant level tak perlu divide dengan 2. Okay, walaupun dekat sini adalah two-tail test, akan two-tail test kan, sebab tapi bila kita conduct F test di sini, the value of significance level for the critical value cannot be divided by 2. Okay, so alpha sahaja dekat sini. Okay, dia punya degree of freedom adalah 1 and minus 2 ni adalah degree of freedom untuk regression dan juga mean square error, mean square regression dan juga mean square error. Okay, kena tengok betul-betul 1 dulu baru n minus 2. Kalau you tertukar, so the value of f will be different. So we will reject hash not if the test statistic more than the critical value. If hash not is rejected, so we can say that the regression model are significant, ataupun we also can say that one of the at least tapi ini adalah simple linear regression, so okay, tak perlu nak mention that. Okay, sorry. If we reject hash not, okay, if we reject hash not means that we accept hash 1. So there is a the regression model are significant. Or you also can say that, you boleh ambil dia punya conclusion ni, there is the linear association ataupun linear relationship between y and x. Okay, so this is the example. Let's say we have two variable y and x here. Okay, to set up the Anova table, first you need to calculate the value of SST, SSR dan SSE. Okay, so here kat sini terus dia masukkan value of beta 1 and SXY, but you need to show, okay, in your calculation after this, you need to show how to find the SXY, which is the summation of XY minus summation of X multiply summation of Y divide dengan N. And then kena tunjuk satu-satu lah macam mana cara you dapatkan SST dan SSR, and also at first point you kena list down all the value of summation of y, summation of x, summation of y square, summation of x square, summation of xy, and so on. Okay, then you come up with the calculation to get the value of all the sum square error, and then lastly you can create the Anova table. Okay, so Anova table kena tulis betul that is the regression error and all the ejaan pun kena betul. Last sekali kita akan dapat value of f, and we can conduct the test to see whether there is significance of the regression model. Okay, so from here kena ada hypothesis, kena statekan dia punya alpha, kena ada value f. F tadi dah ambil daripada Anova table sebenarnya, and then you comparekan dengan critical value. Okay, so cuba check you punya Anova table, how to get the 4.28 here. Okay, you should know that. And then last kali the conclusion, because of we reject hash not. Okay, so we can conclude that there is a linear association between the y and x, and so the regression model is significant. So actually all of this you have learned before this in diploma, but I believe you all dah familiar with this. Cuma maybe tambahan sikit about the tadi kan, the partition of the variability tadi, explanation with together with the illustration of the figure tadi. Alright, so I hope it's clear. Then nanti boleh tanya lagi lah.